Yo, what's up, everyone? So happy you're here, happy you're watching, and what I'm going to do right now is go over the practice test. And what you should know is that when you're reviewing, you have three things to look at this week. You have the free response set, you have the multiple choice set, and then you have this practice test, which I'm sending out on Wednesday with this video. And this might be the most important of the three because it shows the exact format of the test. Okay, so this video I'm going to talk about the test itself, and then finally housekeep on the last things I want to review with you. We have been reviewing a bit, but I want to just cover like everything that we may have missed and cover the important things a few more times. Okay, so the tests we take are going to look just like an AP exam. It's going to start with some multiple choice, and then it's going to do some free response. And for the sake of time in this video, I'm going to skip the multiple choice. But know that the multiple choice on the real tests are going to be different, but cover similar topics. Okay, so this first one, asks you to find the IQR of a histogram, which I am going to cover later in this. This one asks you to find an outlier. So the multiple choice is going to probably cover similar things. So what I want you to do with this practice test is make sure that you take it first and then look at this video for a review. But it's much better to try on your own first. Okay, so take the test and then even look at the answers to the answer key and then watch this video to kind of review the hardest parts. But to start, we're going to look at the free response. So in the AP exam, there's the multiple choice and then there's the free response. And I am sorry that this cuts to the other page, but that's fine. And it says to look at the following box plots. So we have 5 box plots, and let's look at what the question asked before we look harder at them. A says which has the highest standard deviation, and B says which is the smallest standard deviation, and which box plots are non-symmetric. So wait, before I do the question, like basically the test I give you is going to look really similar. This question in particular, I'll probably give you like the same thing on the exam, just a little bit different. But the other 2 questions are going to look very similar. So I wrote those. I wrote these questions, but they resemble AP questions. Okay, but this is really likely to be on the real test, which I'm going to give you tomorrow. So we're looking at these box plots, and it asks us to essentially compare them along a few things. Okay, so first we kind of had to figure out the highest and the lowest standard deviation. I don't know what I was writing there, but you get the idea. And then we have to figure out which of these box plots is non-symmetric. So we're really trying to figure out the shape of these box plots, okay? And that is going to dictate to us what has the highest and lowest standard deviation. Okay, so first, I go over this question so that we can review standard deviation again. And standard deviation measures spread and how far away the data is from the middle. So most of our distributions here have a middle around 5. So we want to know, is the data close to that or is it far away from that? Okay, so the highest standard deviation has far data, and the lowest standard deviation is going to have really close data. Okay, so let's start with the first one, even though that's not going to be the answer for either. And when we look at a box plot, wherever we see small sections is where all the data is. Remember, because every section of this is 25%. So here is a really condensed section of my box plot. So when you're looking at box plots and you have to kind of know some stuff about it, you want to generally sketch what's happening. And if I were to sketch this first one, number 1, it looks to me like a lot of data, not a lot of data, a lot of data, not a lot of data. So a classic kind of bimodal situation. And if I am going to talk about my standard deviation there is some data near the middle, but not a lot, okay? So I'm not going to talk about high or low standard deviation yet, but I would say that this is kind of a middle standard deviation. Okay, so some of the data, the 5 to 6, is really close to the center, but a lot of data is far away too. So we'll call this a medium standard deviation. For number 2, every section is the same, okay? And that's because 2 to 0.5 to 5, 5 to 7.5, that's an equal distance. So that's a classic uniform. So if I wanted to describe my first one, I could call it bimodal, and my second one here I could call uniform. And if you have either of these, it's going to be a medium standard deviation. This is probably the most medium standard deviation you can get, because around half the data is pretty close and half the data is pretty far away. So we're still looking for something that has a really big or really small standard deviation. So let's look at number 3. Here, where's all my data? Right in the middle. So already this is good because the data is condensed close to the center. And if I were to sketch that, that means not a lot of data on the sides, but everything near the middle at 4 to 6. And if we're reviewing right now essentially shapes and their standard deviations and their box plots, this, and I really want to make sure it's on the page, this is a classic this is a classic low standard deviation situation because all the data is close to the middle. So this is my candidate so far for the lowest standard deviation, box plot number 3. But let's look at the next two. The next two are more standard, so I gave you some hard box plots here. But if I was to estimate 4, all the data is on the right side. I do that twice a lesson. Okay. And skewed distribution is usually going to be a medium standard deviation. Because think that the middle of this distribution is actually really far to the right. So think this is the middle. So you have some data close, but you do have some far away. So when you're talking about high and low standard deviation, number 3 and number 5 are your answers. Because this is where the data is close to the middle, and this is where the data is far away from the middle. So both are symmetric, because we do have to talk about symmetric. But this is that symmetric bimodal on both ends. And we will clarify with number 1. Okay? But this is a classic example of high standard deviation, because everything is far away from the middle. So let's write in for A and B that we found our highest standard deviation is going to be this box plot. And that makes a lot of sense to me because this box plot has a lot of data far away from the center. For the lowest, it's going to be 3 because everything's close to the middle. And finally, we have to talk about symmetry, and I think this is good to think about too. And if you're looking straight at the box plots, symmetry is actually really obvious. And that's if both sides look exactly the same. So we can say not the same, 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 not the same, same. And that's going to be the answer to this, okay? So 2, 3, and 5 are symmetrical. And then if you were to look at them, this was bimodal, and I get that this looks pretty symmetric, but I think the way that I didn't draw it that well is it's like a lot of data here, not a lot of data here, a lot of data here, but not a lot here. Okay, so if the middle is here, it's not symmetric. So not symmetric, symmetric is both sides are the same. Symmetric, not symmetric, symmetric. So that's going to be A, B, and C. And then on the test, you're going to have to match histograms as well. And I'm just going to do this based on the sketches I did, but maybe I'll change the order on the actual test. And it asks us to first identify, so this was 5, 4, 2, and 1. And then it asks which one's left, and that's number 3, which was symmetric. And we call this the bell shape or the normal distribution, which we're going to learn a lot more about later in the year. Okay, so that's a standard test free response question, and I'm going to go over the next two now, and we'll continue on there. So I think I'm so far on pretty target time of 30 minutes. Okay, so for number 2, it says during quarantine you got really into Animal Crossing and you record how much you played during a 2-week period, and this is in hours. So that's your data, and this question is like a traditional do stuff with data. So first it asks us to create a frequency chart, and then it asks us to find our statistics. So remember, and I probably won't make you start all the way this far, like on the test I probably won't waste your time with the whole frequency chart, but definitely expect at least part of it. You want to find the frequencies, the relative frequencies, and the cumulative frequencies in different intervals for your data. So when you make your frequency chart, you're always looking for your min, which actually we can already put in. Min is 0, max is 11. So let's go by 2s, okay? So I can put my intervals in first and go from there. And I'm going to put in the tops too, so I'm going to start filling this out. Okay, so I already put my frequencies, and again, you're just counting how many are in each interval. And just a quick few notes: when you make your intervals, make sure that you're in, it's not wrong if you went 0 to 2, 2 to 4, but it's better to make it like 1.99 and then 2, and then you're always aiming for like 3 to 10 of these. Okay, because imagine like I never do like 3 of them because that's like not that useful, and I never do like 20 of them because that's also not that useful. And then also really you want to make sure you have your total. Just to always count. I mean, it's a 2-week period, so it should be 14, but that's kind of a good way to measure. So next we do the frequencies, which is just percentages. So you do this divided by this all the way down, and then let's talk about cumulative. Okay, so then after you do your relative, like in the total, I always put 1 because it should add up to 100% or the decimal 1. And then cumulative, remember that you want to figure out how much data has accumulated by that point. So you can think that we can ask, how many days did I play 4 hours or less? And we would do that by adding up that and that. So that would be the cumulative frequency after the second interval. So you always start by putting in your first number, but then you just keep adding to get to the next one. And then you should always end up at 1. And then again, I'm probably not going to make you do this in the test, but it's good to make you do it in the practice. But I might make you do cumulative frequencies or ask about those. And then the second thing I could ask you is to do descriptive statistics. So again, I'm making you do this from a data set in the practice, but I think it's pretty unlikely that I would make you solve all of this on the test because it's a little amateur, but we got to go back to everything. But the key to the hardest ones of this, oh, and I forgot to give you the standard deviation, so I'm going to give this to you. But the key to a lot of the 5-number summary is to order your data. So yeah, before I do anything, let me order my data. And then I'm also going to find my mean, which is just adding them all up and dividing by. Okay? Okay. So in this class, there's a few ways that we can find our statistics. But if you have a small data set and you want to find your 5-number summary, you should just order it and cross out. Okay, so the next example I'm actually going to teach what do you do with a huge data set, how do you find what data point is the median. But here, if you're at your most basic, we have 14, so it's going to be in between the 7th and the 8th data point to find my median. So 1, 2, 3, 4, 5, 6, 7, 8. And then remember, I even have like a small data set or strategy for this. If it's 2 of them, I'll kind of circle them. But we know that if I'm trying to find Q1 and Q3, this is included this way, and this is included this way. So 14 is a particularly tough number because it's going to be 2 more splits. But you always know you did it right if every part of your data set, I messed it up, that's hilarious. So this is a good check. But every part of your data set should have the same amount. So here it's 2 Q1, 2 median, 2, Q3, and then the final 2. Okay, so that's a small data set, and you add them up and divide. So 0.75 Q3 is going to be, let's just do some quick math, it's going to be 5.85. I feel confident in that. And then the median is 2.75. Okay, good. The range in the IQR, and again, I just wanted you to do this on your own, and I'm just kind of glossing over it quickly because we're gonna get to some better stuff. Range of this minus this, 11. And then the IQR is 5.1. And then I give you this on the thing, so I'm going to edit that in. And I give it to you because it's hard to find on your own. Remember, you would have to do a crap formula, it sucks. But we're going to use it for the change of measurement stuff. So the first thing we're going to try to figure out is, does our distribution have outliers? And when you have the data set itself, you can actually figure it out. And if I'm just looking, we're really trying to figure out, is 11 an outlier? And the way we do this is the 1.5 times IQR method. So I take the IQR and multiply it by 1.5. So this is pretty cool. 1.5 times 5.1. Whoa. And then you add and subtract that from Q1 and Q3 to create a range that's considered normal. So we can actually already see it's not an outlier, but let's do it. Okay, so I just actually ended up doing the whole thing, and I imagine, knowing me, I'll use a fast forward edit here. But let's talk about what I did and what the normal range is. So what you do and how it makes sense is you take your IQR, which measures your spread, and you magnify it a bit by making it times itself by 1.5, and then you take that number and you go further than that from Q1 and above that on Q3. And you really compare that number to your max and your min. In this case, that lower number, negative 6.9, is way below. So there's no way there's an outlier because our smallest data point is 0. Here you would take 7.65 and add it this way and compare it to this number. Okay, so that's why you subtract this way and add this way, and that's the outlier formula. And let's say you didn't have the data set and you just have the statistics. You couldn't list your outliers, but you could predict if they're lower end or upper end, and you can see if the min or the maximum are outliers. So that's later in it, but I might skip doing outliers twice. But the big thing for distributions are center shape, spread, and outliers. So finally, let's look at D, and this is another big topic, which is change in measurement. And if you've done all the multiple choice, you're gonna be really good here. But it says, imagine you wanna calculate your screen time, and you have 5 hours a day for homework, and you don't use your phone for anything else. So the gist of this, and hopefully you understood it, and it's not realistic because you use your phone for other things, is that you are using a screen for 5 hours a day for work, and however long you play Animal Crossing. So you're taking your entire distribution and moving it over plus 5. So in this example, we're going to talk about what happens if you are moving your entire distribution, and think that all of your points are going to go up 5, okay? But your spread measures are going to stay the same. So first, this messed up, but that's fine. Think that on the days you didn't play any Animal Crossing at all, you still used your screen for 5 hours to do homework. And then if you only played for 0.75 hours, you really want your screen for 5.75 because you always are on your phone for 5 hours for, or like your laptop for homework, okay? And again, these statistics are literal points on your graph. And therefore, every single point is up, so these are up by that amount. And then hopefully this makes sense. You know, I'm doing a lot of things again, so I really appreciate you, and hopefully this is easy. But think range and IQR didn't change because the distance between them is still 11 and 5.1. So that movement, adding and subtracting, doesn't affect them. And for the same logic, the standard deviation and variance remain. Okay, and you really just have to remember that this variance is just this number squared always. But we're going to talk about a different kind of change in measurement for the end of the next question. And here's our last question, and first I want you to notice the graphs I made and the question itself, and that's kind of to inspire you for the project a bit. I used the Warriors colors kind of. I didn't think about that till after. But you're going to have to make Google charts for some data that you collect, and these actually came from the real data. I changed it because this data, it didn't work that well. So okay, let me just preface it very, very quickly. Like, I found the real data for this, so I went to Basketball Reference, found the correct data, but the graphs didn't really work for the questions I want to ask, so then I lied about the data. So I did want to use the real data, and this is real data you could use if you wanted to for your project, but that's that. Okay, so this question is saying the following histograms show the number of threes made by Steph Curry and Klay Thompson during their historic 21-game playoff run in 2015. And it just clarifies a bit on the bottom that these points are 8 and these points are 6. Okay, so this should kind of go 8 to 9. This should go 6 to 7. And first, it asks you to compare the distributions. Okay, and here what you'll notice is I didn't actually make you do it on this because this is a question that I ask you all the time. So if you've been doing all the work earnestly, so if you've been doing like the free response packets, this is like such a common thing for them to ask. So I'm going to ask it too. But even though I'm not going to do it right now, one of the last few things I do want to review is finding the median, the IQR, find Q1, the median, and Q3 from a histogram. Okay, and I want to actually give you a few more formulas because I've made this mistake a little bit, and I want to clarify. So first, you always start with your number of data points. So if I'm trying to find Q1, the median, and Q3 for this data set, I start with my number and the median, because we know the median is just the number of data points plus 1 divided by 2. Okay, so that formula we all know, and it's pretty easy. But what can be harder then, and what I really believe is something that I've an error in my teaching, is after you find the median, is there a formula to find Q1 and Q3? Q1, we could be logical here and say that the first 10 data points are the first set, and it's going to be in between 5 and 6. But I'm going to show you a formula for doing this, and it's basically just using 1/4 and 3/4 instead. Okay, so if you ever want to find Q1, your formula is going to be n plus 1 divided by 4. And if you want to find Q3, it's going to be n plus 1 divided by 4, but a 3 on the top. Okay, so think Q1 is like 1/4 of the way, Q3 is 3/4 of the way. So if you were ever tripped up, no matter what this number is, this formula is going to help you find these numbers. So let's figure it out here. It's going to be 21 plus 1 divided by 4, so 22 divided by 4. So we're left with 5.5. And then here it's going to be 3 times 22 on the top divided by 4. So 66 divided by 4, which is 16.5. Okay, so that is going to be your strategy for finding Q1 and Q3. So that was a quick clarifier I wanted. So if you were looking at this particular distribution, we're going to find the 5th one, which is in this, and then find the 5th and the 6th, and then find the 16th and 17th. Okay, so I'm not going to finish that, but that was that concept. We've done it a lot. But let's talk about B, and then we'll talk about D. So B says, on the histogram, sketch where the mean and the median will be for both Steph Curry and Klay Thompson. If they want to look as good as possible, do either of them care about which measure of center you use to describe their performance? If so, which player would prefer which statistic? So as far as our big concepts, we're pretty much covering everything in this video, but we're going to talk about the mean versus the median. And the big idea is that it's asking, if Steph Curry and Klay Thompson want to brag about their stats, which one do they want to use? I mean, probably the mean, because they'd be really lame for just throwing out the median number of three-pointers they made. But regardless of that, we want to think, is one of them going to be higher? Because they would rather say the higher value. So, for example, if Steph Curry had a median of 5, he might want to say that if his mean was 4. Do you know what I'm saying? And hopefully you understand that. Or anytime AP or I ask you kind of a logic question. So we want to figure out if the mean or the median is going to be higher for either of my two distributions. And that relates to symmetry versus non-symmetry. Here, it's symmetric. So if it's asking us to label the mean and the median, they will both be equal in what perceives to be the exact center of the symmetry. So think that symmetry means both sides of your distribution are the same. So this moment at 5.5, both sides, if you were to flip it over, are identical. So the mean and the median, nothing's going to push them either direction. So if you're Steph Curry, it doesn't matter if someone is describing your mean or the median, they're going to tell you the same amount. However, if you're Klay Thompson, remember that the mean gets pushed by outliers. So remember that Klay Thompson is this really streaky dude, and this is actually kind of sad that this is true, but most of the time he wasn't that hot during that playoffs they won, but a few times he gave him a huge boost. So think that the median is going to be lower than the mean, because for him, roughly half the data points are around here, but the mean gets pushed by those two great performances. So if you're skewed right, just remember that your mean gets pushed by the skewness. So if you're Klay Thompson, you actually would want to brag about your mean and not your median. Okay, so on my watch we're at 37 minutes, but I think that's probably way down for you guys, but for the sake of time, we don't need to do outliers again. So we're going to skip C because we just did that. And D is very similar to the end of the last question. And I just want to talk about change of measurement one more time. So it says, imagine you wanted to make a histogram of the number of points they both scored off of three-pointers instead, and each three-pointer is worth 3 points, obviously. It's a three-pointer. So it says, what will happen to the mean, standard deviation, IQR of the distribution? So this is a change of measurement again. So imagine that they shoot three-pointers, and this is the number they made. So sometimes you made 2, sometimes you made 3. But if you make 2 three-pointers, you score 6 points. So you could have the exact same distributions, but the entire bottom would be 3 times as big. And that's because a three-pointer is worth 3 points. So this, think about it as expanding your entire distribution. Everything is times 3. The last one you added, this one you multiply every single data point by 3. And if you multiply, these are affected as well. So every single point, every single statistic is tripled. Okay? So again, let me just show that last example. If you're moving the whole distribution over, so adding, your spread statistics are going to stay the same because every point was moved over. But here, every data point is 3 times bigger, okay? So that means that every single statistic is 3 times as big. Okay, so that's all of that. And if you made it to the end, I'm really proud of you. And I didn't cover everything that's going to be on the test, but you have a really good picture if you do all of this. So on the bottom, I kind of wrote an idea like that. And the test isn't going to look the exact same because that wouldn't be smart of me. But if you do the review, it's going to cover pretty much everything, or actually every single thing that can be on it. Okay, so the practice test, pretty much with the multiple choice as well, has everything you need. And at this point, you have all the resources. So I'm going to give you that test on Thursday. But yeah. Woo.